Okay, so let's start it. So probably today, so we are going to discuss about MVCC and vacuuming, which is a very important concept. Okay, so from day one, we are saying like this MVCC is very unique in Postgres and it's very core part of Postgres. Okay, so we are going to cover these modules like what is MVCC and how it is different than other RDBMS, and we are also going to discuss what is a transaction IDs and transaction ID wraparound situation and how the undo segments will be managed in Postgres, followed by vacuuming. So we also discuss what is a vacuum and why we need a vacuum and what are the types of vacuum we have and what are the main important settings we have to enable as a part of vacuuming, and what is an auto vacuum and full vacuum. What is the difference between auto vacuum and full vacuum, and some tips. Okay, so these are the modules which we are going to cover today. So before we go in depth of MVCC, first let's correlate this same topic with Oracle. Okay. So for example, if you have a record or a row, when multiple sessions is trying to update or write that particular row, so in Oracle, what happens? It will we have a locking technique where it will lock your record until the first transaction either commits or rollback, right? So this is a known fact in Oracle. We know this thing. And for read consistency, it also have a segment called undo segment, okay, which will save its pre-image copy, right? So this is in Oracle, right? So in Oracle, we have a locking technique. It is a row level lock, right? So it has a shade lock and exclusive locks. Based on that lock only, your data will be in consistent state in Oracle, right? Okay. Now, when coming to Postgres, what happens? We don't have any undo segments here. Okay. So whenever you do any transactions in Postgres, what happens? Like for example, insert or it's a update or delete. Okay. What happens is internally it will create a new snapshots of that particular version or snapshot, whatever we call. Okay. So it generates a new snapshot, and for example, if that particular session is not yet committed, okay, so here the main important thing is that snapshot or that particular tuple visibility is very important here, okay, based on the previous commits or previous uncommitted transactions. Based on that, the snapshot will become visible or invisible. Okay, that is main important. Okay, so basically this MVCC technique in Postgres is for data consistency purpose. Okay, so when you correlate the same with so when you correlate the same with Oracle, okay, Oracle have the locking technique, and based on the locking, it will we have the consistency of data, right? Similar way, MVCC comes into picture, or basically the architecture of Postgres is mainly designed based on this MVCC technique only. Okay, so this MVCC technique, how it works is whenever you do multiple transactions at the same time, okay, internally the MVCC technique will be applicable, and it takes off its consistency. How it takes off its consistency? Instead of it provides a lock on that particular row, okay, it will generate a new snapshot. New snapshot means, so it creates a new row. It creates a new row version. Okay, for example, you are doing some insert statement and followed by multiple updates. Okay, so you are doing first update. So what happened? The previous image data will be, for example, marked as one snap or one version or one snapshot. And when you do an update, it generates a one more snapshot, which means one more row it will generate in the same table. So the since it doesn't have separate undo segments, it won't store the pre-image data in a separate undo segments or something. It stores in the same table until that particular transaction commits. Okay, that particular row will be visible. Once the transaction is committed, that row will be invisible. So which we call it as a dead tuple. Okay, and whatever the latest snapshot data which is committed data is called as a live tuples. Okay. So this is this is the basic core of the MVCC. So what happens in MVCC for consistency purpose. Internally, it generates a new snapshots in the same table, okay, and it maintains the consistency. And this snapshot row, or we can call it as the latest snapshot row, we have to mainly concentrate on row visibility or tuple visibility. Okay, if this snapshot, if the current latest version, okay, still have the previous commits, then that particular row still have the row visibility of the previous snapshots because it's not yet committed, right? When you commit it, then that becomes the live tuple and that becomes the latest snapshot, which is the consistency. Okay, so we'll see one few examples to understand better. So basically MVCC technique in Postgres is basically whenever you do multiple transactions for read consistency, it creates a multiple snapshots in the same table. Okay, and the advantage of this MVCC technique when compared with other RDBMS is basically readers don't block writers and writers don't block readers. Okay, so you don't get any kind of locking when you when you do read operations, you don't get the right so the locks on the right operations, okay, and vice versa. Okay, so this is one advantage in MVCC. Because of this advantage, what happens internally? So your application performance will be improved. So you don't see much locking wait events like so like concurrency locks. Okay, we don't have we don't see much wait events here with this MVCC technique. But in Oracle, it's a row-based lock. Okay, you could see more wait events, right? So because of that, you may see some performance impact on the application. But in Postgres, your performance will be very good because of this MVCC technique. Okay, this is one advantage in Postgres, right? Your application is compared with Oracle, it's very fast because you don't have this because of this read don't block writers and write don't block readers advantage, because it creates multiple snapshots in the same table and you don't have lock in this situation. Okay. And internally it uses one algorithm called serializable snapshot isolation. Okay, basically this algorithm, based on this algorithm only MVCC manage the consistency. Okay, so we'll see how it manage the consistency whenever you have the conflicts on the transaction, like multiple transactions are performing at the same time. Okay, how this serializable snapshot isolation comes into picture and how it helps the MVCC, that we'll see. Okay. Let's see one example how MVCC works. Okay, so here what happens, I'm doing insert followed by two updates. Okay, and if you see here, it manages the row versioning. Okay, here what it is doing, this is my this is a new table which I have created, and this is the row data and followed by row header. So in row header, we have some system columns, system columns. We know one system column is CTID. Okay, so the CTID is like row ID in Oracle. Okay, so this CTID have the page and line pointer. Okay, so this is page 1. Basically, pages start with 0. Okay, assume that, let's consider this is a page 0, and this is a line pointer. Whenever you do first insert, your row will be inserted in the table, right? So this is my row. And suppose this row is currently in P01, which means page 0 at line pointer 1, you have this particular row. Okay. Next, what I'm doing an update statement. So whenever I do an update statement, what it does is it copies the entire row into a new snapshot. Okay. And here it will modify. So basically, update is nothing but insert and delete in Postgres, right? So what internally it does is it will insert a new row and it will modify here. Okay, it will copy the previous version of row here and it will modify in the new version. So this is called new snapshot. Okay, it is creating a new snapshot here. Let's assume, so here also we can consider the page 0 and line pointer 2. Okay, so here page 1, page 2, page 3 is 3 different pages. Probably once the first page is full only, then it will go to the second page, right? So until you fill the 8 kilobytes of your data, right? So here, for just example purpose, we are showing into different pages. It may be the same page. Okay, this particular 3 records may be the same page, right? Now I'm doing the second update. So whenever I do the second update, what happens? It will copy the previous row version into the new snapshot, and it will modify the blocks here. Okay, which means it is keep on generating the new versions of rows, right? So this is one drawback in MVCC. So what advantage we get in MVCC? We got readers don't block writers and writers don't block readers. With this advantage, your application logic or your application performance will be good when compared with Oracle, because here you don't have this kind of locking in this situation, right? But whereas in Oracle you have shared logs and exclusive logs whenever you do write and read operations, right? Here it's because of the new snapshots which it's keep on generating, you don't have this kind of issues, locking issues, and you don't have that kind of wait events you could see regarding the logs. Okay, but disadvantage is since you don't have separate undo segments, whenever you do an update statement, okay, for example here, the first update, what it is doing, it is copying the previous row version into the new snapshot, and it is modifying your data here, right? Until this transaction commits, okay, the previous image of this data will be marked as, until the commit, it will be visible, right? Once you committed the data, okay, it becomes dead, right? That particular record is no longer valid, but still it is present in the same table. Remember that point, okay? For example, in this example, we are doing second update, right? So second update, whenever you are doing, it is copying the previous row into the new snapshot, and here it is modifying. Once it is modified, whenever you commit the transaction, the previous image is marked as dead, right? Because already the new latest version update is present here. All the other transactions will read the new data, new snapshots, right? So this is the row visibility, but this row is marked as dead, and it is storing in the same table, okay, not in the different segments or any other tables. So the pre-image data or undo segments will be saved in the same table. Because of this, what happened? Your table size will keep on growing because of the new multiple snapshots which it is generating, and your date tuples will also keep on increasing, right? So to avoid this situation, we have a concept called vacuuming, right? So to delete this kind of old versions of date tuples, okay, so you have a concept called vacuuming that we are going to discuss. Okay.
Suresh, can you please write some diagram regarding pre-image and post-image, how it is happening for first update and second update?
See, here in this diagram, what happens when you do a first update, it is copying the same image copy from the previous, because this is an insert statement, right?
The which block, the first block or second block? Here I could see second block and third block is filled, right?
Don't confuse about blocks. This
okay.
page, assume this all is page 0. Okay, this 3 rows are in the same page. Okay.
Okay.
It is copying the exact row version into the new snapshot in the same page. Okay, so the page may be different. Okay, here I have mentioned.
Okay, understood.
P3 is just for understanding, but your 3 rows may be in the same page. It will be not in a different page, right? Because the goal of the page is at least it has to fit 4 records. That too, not like simple data type. It has to fill, if you have the text data type, which is like equivalent to C log, at that moment only it will fill. Otherwise, when your data types is normal, integer and float, okay, you don't have that problem. So assume this is a page. Inside the page we have 3 rows, 3 snapshots of rows. Okay, since it is a first insert, I don't have any pre-image data. It will directly go and fit your insert your data in the row data side. Okay, and it has, each row have its own row header, right? And row header have the system column called CTID. So this is the first insert. This is clear, right? Because it doesn't have any pre-image data and it is a fresh record, and it is directly fitted in a row as a one row version. Assume this is a version 1 or snapshot 1. Okay, now second what you are doing, you are updating the record on the same insert, whatever you did. For example, in this,
You are sharing something.
no, I'm sharing the slide itself. Yeah.
Okay.
So here, assume that I have a EMP table having employee name and salary. Salary is 1000 here. Okay. Now here you are trying to update from 1000 to 2000. So what it does, basically, it copies the entire snapshot into a new row version. Okay. And it also have a separate row header and row data, right? It copies the previous image, or we can say previous version here, and it will modify your salary 1000 to 2000. Okay, once you modify, still you are not committed. Okay, I assume that you are not committed. Okay, and one more session is trying to update the same snapshot. Okay, this is the base snapshot, right? And what happens, it is also copies from here the first insert, and it will have the separate snapshot. Okay, both transactions have separate snapshot. Now assume that these two versions is still visible, right? Because this two is not committed. This two is still valid, or this two tuples is not become dead because this two is not yet committed. Okay, this two tuples is both are dependency, right? On this particular base row. Okay, now both updates is not yet committed. Assume both updates is not yet committed. Some other transaction is trying to read the data. So what snapshot they will get? They have this snapshot, right? Because still these two snapshots is not yet committed. So they will get this particular data, right? Now assume this particular update is committed. Okay. So once this particular update is committed, okay, and this is the new snapshot, and this update has to update on this snapshot, right? So it will copy this snapshot again, okay, in this particular row, and it will modify. So once this transaction is committed, the pre-image version will become dead, okay, because this is the previous version, right? And we call it, see, the only difference in Oracle and Postgres is your pre-image data will store in a separate segment, and your live data will be stored in the original table. Here, instead of that, it stores in the same table as a previous version. Only that is the difference. Okay. Other than there is no difference.
Okay.
Yeah.
Yeah. Yes, Suresh, I have one question. See, you see when you said that before when a record is being modified, the snapshot is maintained in the same table is what you said, right? So let's say the ex user is trying to access this record. So for him, the snapshot is visible or the actual record is visible to him?
No. If that particular record is not committed, the snapshot will be visible. The previous snapshot will be visible to him. Whenever you do select start from EMP, and the 1000 rupees is not yet committed, same like Oracle. So when you do commit or rollback, see, basically in Postgres it's auto commit. If you want to control commits and rollbacks,
right.
We have to manage with the begin class. Okay. So for the other users, it will be visible in the previous snapshot because this current version is not yet committed. So same like Oracle only.
Okay, and at the same time, so as a as a DBA, we can see the snapshot on the table, or it's like it's not visible. I mean to say, is there any?
We can see basically the entire snapshots will be managed with the help of some system columns. Okay, based on the transaction IDs, there is two system columns called xmin and xmax. Based on that, we can see whether the tuple is visible or it's not visible. So if it is marked as a dead, okay, once the transaction is completed and it is marked as a dead, we cannot read from the select statement, but we can identify whether it's a dead tuple or row tuple based on the some dictionary tables and some system columns.
Okay. Thank you.
Yeah. So this is how the row versioning will happen in MVCC technique. So so whenever you do any DML statements or so what happens is it's keep on generating a new snapshots, and here the main important is tuple visibility and tuple not visibility. Okay, tuple visibility means if the particular transaction is keep on, okay, let me explain in, so let me take one Excel sheet so that it will be better to understand. Let me stop and share it again. Okay, so assume that every transaction have a transaction ID. Okay, currently I'm near transaction ID 100 and transaction ID 200, 300, 400, and 500. So for example, these are my transactions. Assume that this transaction is committed. Okay, transaction ID 100 is committed, 200 is not committed, 300 is not committed. Okay, 400 is not committed. So when you do the 500 transaction, so these three records is still visible because this three is not yet committed. But the transaction the transaction which is committed is marked as dead tuple. Okay, this is marked as dead, and this is no longer, this snapshot is no longer used by any other user, or they cannot able to fetch, right? But whenever your transaction is not yet committed, currently you are in the transaction ID 500. Okay, the previous snapshots or the previous row versions will be still visible or still valid, right? Because this is not yet committed, and the future transactions, whatever you are doing, is entirely depends on these transactions, right? So assume this transaction is committed now. So when this transaction is committed, this also marked as dead, right? Because it's already committed and it has the latest, so the latest snapshot would already be applied, right? So and so on. This is how it works. Okay, so we also explain one example by taking one table in the slides so that you will also understand easily. Okay. So for example, I have a table called inventory. Okay, and it has these many columns: product ID, product name, description, amount, and customer name. This is my columns. Okay, and it has this many records. Assume that I have a product ID 100 and 121. Amount is 500 USD dollars, right? Now, in this case, transaction T1 and T2 are trying to update same amount value from 500 to one transaction ID is updating to 550, the other transaction is updating to 580 at the same time. Okay, so let's, okay, so I'm having two transactions. Transaction T1 is trying to do an update statement, and that is trying to update from 500 to 550. Okay, and other transaction is also trying to update at the same time from 500 to 580. Okay, which means two update statements it is trying to perform at the same time in this particular table on this particular row. Okay, based on this pair condition 10012, I'm trying to update this amount value from 500 to 550 and 550 to 580. So in this situation, what happens? What MVCC will do? It creates its own snapshots. Okay, this is transaction T1 and this is transaction T2. Okay, first it will create its own previous snapshots. So the previous snapshot is 500, right? So it has its own previous version snapshot. Okay, T1 has its own snapshot, T2 has its own snapshot as 500 because the base value is 500, right? This is the base snapshot. On the top of this base snapshot, what happens? It will create its own snapshot, T1 and T2. Okay. Now, what happens is it will update on the snapshot. See, this is 500, right? It creates its own snapshot as 550. Okay, see here, if you see it, this is the new version. Okay, from 500 to 550, it has updated T1. Similarly, T2 also has the base value 500. It also tries to update to 580, right? So this is still not yet committed. Okay, this is just modifying still. Okay, both update statements are still modifying. This T2 is still assuming that 500 is its own snapshot. T1 is also assuming 500 is own snapshot, right? And T1 is not committed, T2 is not committed, and still it is trying to modify its own snapshot as a new versions. Okay. Now assume that T1 is, for example, T1 is committed. Okay. So whenever T1 is committed, now the previous version 500 becomes dead, right? And this is the new latest version 550. But how T2 knows this 550 is the latest version? Okay. Here the MVCC serializable snapshot isolation algorithm comes into picture. So what it does, whenever any transaction commits, it updates the new value as a latest snapshot. Okay, currently whatever transaction which is ongoing, it will have the latest version. Okay, with the help of serializable snapshot isolation algorithm. Okay, this all internally happens. We don't want to worry about it. Okay, so now when coming to here, so what happens? The latest version becomes 550 now, right? Because the T1 is already committed. Now T2 transaction, internally what happens? It get a serialization error internally, which means it is not having the latest version because still T2 have 550 as its own snapshot, right? It has to update as a 550. So what happens is a serializable snapshot error, internally it triggers an error and it will update 550 as the new snapshot. Okay, on the top of 550, T2 transaction will update to 580. Okay, this is how the multiple versions it manages, and the serializable snapshot isolation algorithm will take care of your consistency of your snapshots. Okay, if the current transaction is committed, then always this algorithm will keep on updating the latest snapshots, and parallelly whatever the transactions which is ongoing, so those transactions will be have the latest version or latest snapshot. Okay, with the help of this algorithm, it will manage. So this is how the MVCC technique will work in Postgres. So any questions here? So internally how it will identify means it has some system columns. Among the system columns, two important system columns is xmin and xmax. Okay, so whenever you do any insert statement, your xmin value will be updated, and whenever you do any update or delete, your xmax value will be updated as your transaction IDs. So based on the transaction IDs only, this MVCC or Postgres will identify and it will manage the consistency based on the number of snapshots. So what are the system columns we have, and how it will update, we will see in the coming slides. So this is just a simple example how MVCC works. So MVCC will create multiple snapshots, and your consistency of your rows will be based on whether you have committed or not committed your transaction, which we call it as a row visibility or row not visibility. If a transaction is committed, the previous snapshot is no longer valid. It becomes, or it marks as a dead. If your transaction is not committed, still that particular versions will be visible, right? Because it's not yet committed. Yeah, any questions? Yeah. So if no questions, then we can discuss about the transaction IDs.
Yeah, what is this algorithm you said? Serialization isolation algorithm?
Yes, serialization. Okay, so this is the one, serializable snapshot isolation.
Oh, okay.
Yeah, and one more thing here, you can see here in PostgreSQL, update is nothing but it is going to insert the data and it is going to delete the old data. Okay, just keep in your mind. And each and every transaction, okay, either it may be update, either it may be delete, either it may be select. Okay, so every transaction is having its own snapshot. Okay, So it is not directly going to modify, not directly to do anything on our original table. Okay, so everything, every modifications or maybe retrievals, everything is coming from the snapshot, not from directly from the original table. Okay, so that is the beauty of PostgreSQL MVCC.
So when the commit is happen, that time it will actually change the original table or the snapshot table.
No,
It will
change
whenever there is a commit operation happened. Okay, so in this case, it is going to change an original table.
Okay.
Okay, so up to the modification, everything will happen on the snapshot. Okay, whenever if you perform the commit operation, it is going to store permanently on the your original table. Okay,
permanently will store in the original table as a new version. Okay, not on the same version. As a new version, it will save.
Committed operation. So
Okay.
You are audible, my voice?
Yeah, I'm audible. You're audible.
Okay. So whenever if you committed the operation, so in that situation, the data will be stored permanently into your table, original table. Okay. So that's why whenever the committed operation happens, so the pre-image data, okay, the pre-image data become the dead. It means no visible, no more that is visible. As Suresh is explained in the Excel sheet, right? Okay. So those are the we can say the dead tuples are invisible transactions. Okay, those data is not at all visible for any future transactions.
So that dead in the sense that will get that. Hello.
Yeah, can you repeat the question, please?
No. What? Sorry. What I'm saying, the dead tuples, right? Invisible that row that will be that is having some like MB or some KB size in the pages, or is a 0 KB only, dead in the sense.
No. It is holding. See, that is nothing but it is data only, but it is not visible for any of your transactions. Okay. It will be stored into your own table. Okay, in the same table. Okay, and along with the live tuples. So it means so that is the reason MVCC is coming in the picture to clean up. Okay, to clean up all your dead tuples from your original table to improve your performance. Okay, so yeah.
So only the data integrity here it is maintainable by the committed operation only. Until the data is committed, it will be data will not be visible to the end user. Once it is committed, then only we will be able to see the data. Till that time, whoever is able to change the data, they can able to change independently without blocking anything. That's what is happening, right?
Exactly. This is here the behind the scene is it is using the MVCC technique by multi-version concept. Okay. In the PostgreSQL.
Okay.
Yep.
But in order,
Snapshot will be available. So that means if the transactions gets committed, so that will consider as a dead couple and the users cannot be accessible, right? That old image.
yes.
Yeah, the pre-image data, yes, it is not accessible.
Okay, what is the recommendations that we can give if users can give 1 million records update or delete?
You see, whenever you want to do any bulk updates or inserts, okay, so you have to use a concept called cursors, okay. So every 100 tuples or maybe every 200 tuples or every 1000 based on your amount of data which you are trying to load, you have to do a frequent commits, okay, and you have to control with the help of begin class, okay. You have to write a PL/SQL code or PG/SQL block for by using cursors, okay. You can hold this many records at it will process in the cursors, okay. Once it is done, it will commit and again it will process the remaining. So this is how the good practice whenever you do bulk update or insert statements, okay. Even in Oracle also same, right? So
so even it's applicable for delete also, right?
Yes, correct. It will also applicable for delete.
Okay.
Yeah.
And each transaction is committed by default, right? It's an auto commit. And what I meant is, let's say your user is trying to insert some 1 lakh records, and these records are before Postgres commits these transactions, it creates a snapshot of all these records and does the commit.
Yes, if you are passing multiple statements, it will create multiple versions. But if when you do an update statement, it is trying to update like almost 1,000 records, then only one snapshot will be created, and it will try to modify that records in the new snapshot. Okay. If based on the loop, how many loop it repeats the statements, that many snapshots it will generate.
Okay, so even if you're trying to insert 1,000,000 records, it will create only one snapshot?
Yes, exactly. If one insert in a one go, for example, in maybe in a block you are passing, then it will generate one snapshot.
Correct. Correct. Just adding to Suresh Banu. Okay. Here maybe you connected to your database. Okay, the PostgreSQL database. Okay. So you are doing the insert operation on the single table. Okay. So and maybe you are doing like maybe 1,000 or maybe 10,000 of insert statement or update statement. Okay. Then the particular related table, the snapshot will be unique. Okay. Then the same like you can say in the like the transaction. Okay. You are trying to update some other table. Okay. Then the snapshot will be relinked to another table and do the operation for the same to maintain the data consistency.
Okay.
Yeah.
So this is some basics about MVCC. And now we also need to understand about the transaction IDs, because your MVCC is mainly depends on your transaction IDs. So it will manage with the help of transaction IDs, and it will uniquely identify that particular transaction with the help of transaction IDs. Okay. So what is a transaction ID basically? So transaction ID is for every transaction. Okay. It will generate a unique transaction ID. So basically in Oracle, we have a SCN number, right? So for every transaction, it will automatically keep on allocating the SCN numbers. In Postgres, the same SCN will be represented in two formats. One format is transaction ID, the other format is LSN number. Okay. So for each transaction, automatically it will keep on assign the transaction IDs, and that transaction IDs will be taken care by transaction manager. Okay. So we have a transaction manager component, and it will keep on allocate the transaction IDs for each transaction, that we call it as a TXID. Okay. Transaction ID. Okay. And this transaction ID is basically a 32-bit integer. Okay. And the maximum limit of your transaction ID is 4.2 billion. Okay. So you have a limitation in Postgres, transaction ID limitation, which is 4.2 billion, 4.2 billion records, or to 4.2 billion transaction IDs. Okay. Not records. So among this 4.2 billion, 2.1 billion is for visibility, which means for future transaction, and 2.1 billion transaction is for previous transactions. Previous means the past transactions. Okay, 2.1 is for past, 2.1 is for future. Past means date tuples, right? The previous past transactions. So not all transactions, all the previous past transactions are marked as a date, because few transactions may still not committed. Those is still point out as visible, right? So it has to split. So in simple words, we can say 2.1 is for date tuples and 2.1 is for live tuples. Okay, so in simple words, we can say like this. Okay, all the previous transactions, whatever you perform, it has some limitation 2.1, and the future transaction which we are going to perform is for 2.1. Okay, this point you have to remember. So total is 4.2 billion transaction IDs it will generate, not beyond that. So whenever you reach this limitation, you have situation called transaction ID wraparound that we are going to discuss in the coming slides. So for now, we have to remember transaction manager will keep on allocating the transaction IDs for each transaction, and it can allocate maximum up to 4.2 billion. Among 4.2 billion, you have 2.1 billion for past tuples and 2.1 billion for future tuples. Okay, this you have to remember. Now, apart from these transaction IDs, apart from this 4.2 billion transaction IDs, you also have some special transaction IDs. Okay. So these special transaction IDs are introduced in version 8 for your transaction ID frozen. Okay, to avoid your wraparound situation, basically. Okay. So 0 is which it marked as invalid transaction ID. 1 is like bootstrap. 2 is for frozen transaction ID. Okay. Sorry. So these are the special transaction IDs. This will come into picture whenever your wraparound situation comes into picture. Okay, this special transaction IDs will be updated. Okay, otherwise your 4.2 billion transaction IDs will keep on update, and this special transaction ID will remains as a default. Okay, so these special transaction IDs they have introduced from version 8. Okay, why they have introduced we will understand in the coming slides. Okay, so transaction ID wraparound situation. This is important. Okay, so as we discussed in the previous slide, we have a limitation called 4.2 billion. Okay, so whenever your 4.2 billion limit is reached, you will get a situation called wraparound situation. So whenever you get this wraparound situation, what happens? Your cluster before version 8, your cluster will reboot. Okay, and again it will start freshly, and it will do a forceful vacuum, and it will do the transaction ID freeze, and it will start again from 1. Okay, this is some disadvantage in Postgres, right? Up to version 8. So that's why people used to think to choose your database as a Postgres up to version 8 because of this problem. Okay, this problem has been overcome after 8 based on the transaction ID freeze operation is automatically taken care by a vacuum process. Okay. So what happens? There is a parameter called vacuum freeze minimum age. Okay, the default value of this parameter is 50 million transactions. So whenever it reaches 50 million transaction IDs, so your auto vacuum process will check whenever it reaches the limit, it will do a transaction ID freeze. So what is a transaction ID freeze? In this example, okay, these are the past transactions, and these are the future transactions. Among the past transactions, whatever the tuples which is marked as dead, okay, those transaction IDs will be reused in the future. This is called transaction ID freeze. This operation will take care by a vacuum process, auto vacuum process. Okay, you are reusing your past dead tuples transaction IDs to the future transactions. When you reuse this transaction IDs, you don't get this wraparound situation, right? So whenever a transaction ID reaches the 50 million transaction IDs, it will reuse the future transactions. Okay, the past transaction IDs will be reused in the future. So this is one advantage. Okay, so that you don't have this situation called wraparound situation. You don't get this wraparound situation now because you are reusing your past data pools related transaction IDs to the future. And who is taking care of this? This technique we call it as a transaction ID freeze. Okay, so this transaction ID freeze will be taken care by automatically by auto vacuum process. So whenever you do any vacuuming, it not only deletes the data pools, but it will also check for your transaction ID freeze. Okay, if this particular transaction ID freeze happens, it will reuse your transaction ID for the future use. This is keeps on going in a circular manner. Okay, to avoid this wraparound situation, and you will never reach your 4.2 billion transaction limit. Okay, because you are reusing those past 2.1 billion transaction ID to the future 2.1 billion transaction IDs, and this keep on going in a circular fashion to avoid your wraparound situation. So you don't have any issues. Okay, maximum you don't get this situation, but still there are some cases. Okay. For example, your vacuum process is very busy and it is trying to skip to do vacuum. Okay, at that moment, you may have this transaction wraparound situation, but it is very rare. Okay, so what you as a DBA, what we can do is we can set the monitoring for this wraparound situation. Whenever your transaction ID's limit reaches, okay, up to at least 1 million. So we have 2.1 billion, but it reaches half of that transaction IDs, we can get a warning message automatically in the alert log. See, for example, in the next slide, this is one example. Whenever it reaches 1 point, maybe more than 1 million transaction IDs, you will get a warning like this in the database alert log. Database Finland must be vacuumed within this many transactions to avoid database shutdown. Okay, so whenever you have this transaction wraparound situation, what happens? Your cluster will be forcefully shut down and forcefully vacuum process will happen. Okay, to clear your wraparound situation. So you can configure your alerting like this so that you can do a vacuuming manually as a DBA. Okay, so that it will use the future transaction. Anyhow, your auto vacuum process will take care. This is a very rare situation you will get, but still as a DBA, we have to configure alerts for such kind of warnings and errors. Okay, for example, you reaches already 1 million transaction IDs and you haven't performed any vacuum. So probably you have disabled the auto vacuum process and it's keep on generating your transaction IDs. And whenever your transaction ID wraparound situation reaches, so you have already done an update statement of up to 4.2 billion records. What happens? It will give an error and your error message looks like this in alert log. Database is not accepting any connections or commands. To avoid wraparound data loss in the database Finland, it is telling once you stop the cluster, okay, once it forcefully stops the cluster, you have to start your cluster in the single user mode. Okay, and you have to do forcefully this vacuum and then it will start again your transaction IDs from 1. Okay, so this is how it works. Okay, so as discussed, most probably you don't get this wraparound situation because your auto vacuum process will keep on reusing your past data pools related transaction IDs for the future. So this mechanism, we call it as a transaction ID freeze, and transaction ID freeze will automatically taking care of the vacuum process. Okay. Now, as discussed, whenever you create any table, for that table you have a columns, and for that columns you have system columns, which is invisible. So two of the important system columns is xmin and xmax. Okay. Based on these two system columns only, your MACC will work actually. Okay, what happens whenever you do any insert statement, your xmin value will be updated as a transaction ID, and whenever you do a delete or update statement, your xmax will be updated as your transaction ID, your current transaction ID. Okay, so based on this two xmin and xmax value only, it will identify the multiple snapshots, whether the previous xmin or xmax value will still visible or not visible, it will identify based on this transaction IDs. These are the two important system columns. Even we can see the output of the transaction IDs of these two system columns. Okay. So any questions here? So if your transaction ID is greater than the committed tuple transaction ID, then we call it as a tuple is marked as a old, and it is, you know, visible. And if you see this formula, so based on this formulas only, it will identify your transaction ID is currently less than with your committed transaction ID, or it's greater than your committed transaction ID. Based on this formula only, it will identify whether tuple is visible or not visible. Yeah, someone is asking some question. Please go ahead. Okay, so hope you understand this wraparound situation. So wraparound situation is because of the limitation of transaction IDs. We have, once the limitation is reached, we have this situation. Okay, to avoid this situation, vacuuming process will do vacuum freeze. So what is vacuum freeze? Whenever this limitation is reached, okay, this 50 million transaction is reached, the past data related transaction ID will be used for the future. Okay, to avoid this wraparound situation. Any questions on MVCC? This is about MVCC. Okay, probably tomorrow we will go through in depth about vacuuming process. Okay, so if you have any questions, please feel free to ask on the MVCC technique.
Here, the tuple visibility, we are talking about the dead tuples or the general one?
Invisible means it is like dead tuple, right? Because the dead tuple will be no longer visible whenever you do select start from table, because that is an old version, it will not show. Okay, so that particular tuples we call it as a dead tuples, right? So whatever the snapshot which is still active and it is not committed, those all we call it as a tuple visibility. So those tuples are still invalid and it is visible. Because
so based on this formula, even though if the data getting committed, still we will be having a chance to see the old tuples based on the first formula.
No. Here committed tuple XID means the previous committed XID. Okay, if the current XID is greater than that, which means
understood.
Yeah. So based on that only, it will identify whether the tuple is visible or not visible. If it is less than, then definitely your transaction ID is still, it has to use this. Okay, based on this only, it will identify whether your tuple is visible or not visible.
Okay.
And this warning and errors are very important. You have to always search for your alert log, and if you have any kind of this transaction ID wraparound situation related errors, it has to notify to DBA, and mostly we don't need to take any action because auto vacuuming process will keep on doing the transaction ID freeze to avoid this situation. Okay, but still we have to enable these two warning and errors in the monitoring. Okay.
So in the previous slide, we say the one parameter, right? 50,000 records.
Yeah, 50 million transactions. Yes.
So based on this value only, the transaction freezing is happening, right?
Yes, correct. So whenever it reaches this limit, 50 million transactions, auto vacuum process will keep on check whether the limitation is reached, 50 million transactions is reached. Okay, whenever it reaches, then it will do recycle. Okay, not all transaction IDs, only the transaction IDs which is already dead. Those transaction IDs it will use for the future.
Okay, but in real time, what value generally in the project team will use? Either the same 50 million or
same 50 million, same 50 million. This is recommended, and it's already, they already did so many benchmark tests and they have decided this value by community. So probably we should fix to the same value.
Okay. Thank you.
So any other questions?
Yeah, if you have any questions, we'll come tomorrow.
Yeah, sure. Done. Yeah, so if no other questions, probably we have a few questions on the backups, right, which Darpan has asked. Probably we will show that tomorrow whenever we start practically on the vacuuming process. Before that, we'll show how the archives will be managed and what utility we use to clear the archives. Okay, that probably we will show when we start the practical part regarding this MVCC in vacuuming.
Okay.
Yeah. Yeah, if no other questions, probably we can catch up tomorrow for vacuuming. Okay, and followed by a demo.
Thank you.
Yeah. Thank you all. Bye.